So first surface, that is 5x squared minus 2yz minus 9z equal to 0. You consider that is 5. So phi of xy is equal to 5x squared minus 2yz minus 9z. And next surface you can consider that is psi of xyz, that is equal to ax squared y plus bz squared minus 4. Then del phi is equal to, you need to find out the del phi del psi value at the particular point. So now del phi is equal to, differentiate partially with respect to x, the first phi. So we'll get that 10x minus 9 into I. This value is x value, okay, not z. This is x value, 9x. So this is 9x. So the term x is involved here. So the partial differentiation of phi with respect to x is 10x minus 9 I vector. Then second term is partial derivative with respect to y. So you have minus 2zj vector. And the last one is partial differentiation of phi with respect to z. So you have minus 2y k vector. Now the given point is 1 minus 1, 2. So at the point we need to find out the grade phi. So grade phi at 1 minus 1, 2 is equal to, so just substitute in grade phi as x, y, z as 1 minus 1, 2. Then we get this one, I vector minus 4j vector plus 2k vector. Then del psi, gradient of psi, you have to find it. That means you have to differentiate partially psi with respect to x, y, z. So you get to that, then you are partially differentiate with respect to x. You have the value is 2axy into I vector. Then dou phi by dou y j vector. So dou psi by dou y j vector is this one, ax square j vector plus dou psi by dou z k vector, that is 2bzk vector. Now again, and that we need to find out the gradient of psi at the point 1 minus 1, 2. So that is minus 2ai vector plus ij vector, aj vector plus 4bk vector. Just here, del psi, gradient psi, you have to replace x, y, z as 1 minus 1, 2 respectively. So now we are getting the two equations. Now in the problem they have given the two surfaces will be orthogonal at the point 1 minus 1, 2. So the condition is if the surface normals to the two surfaces at 1 minus 2, 2 are perpendicular. Orthogonal means they should be perpendicular. Perpendicular means that corresponding to vectors dot product should be equal to 0. So here the normals to the two surfaces at the point are perpendicular. That is the condition for. Now you know that the normals to the surface is not surface. So that means the gradient of the two surfaces are perpendicular to each other at the particular point. So the gradient, both the gradients are vectors. Okay, so gradient of the surfaces are perpendicular means the vectors are perpendicular. The condition for perpendicular vector is, suppose A and B are perpendicular vectors means A dot B equal to 0. Okay, so here del phi, grade psi are perpendicular to each other. Therefore, del phi dot del psi equal to 0 at the point 1 minus 1, 2. At the point 1 minus 1, 2. Okay, so therefore, just you substitute the grade phi, grade psi at the particular point. Already we have found out. That is from the first and second equation, you substitute the values. So you are getting this one. That is I vector minus 4j vector plus 2k vector dot minus 2ai vector plus aj vector plus 4bk vector. This is equal to 0. Then just you find the dot product of these two vectors. The dot product is nothing but you have to multiply the corresponding, you have to multiply the corresponding coefficients of I, j, k. The remaining products when becomes 0. So here the coefficient of I vector here 1, here minus 2a. So the first term minus 2a. Then here minus 4 and a. So minus 4a. Then 2 and 4b. So we have 8b. 8b equal to 0. So we are having the value here 8b minus 6a equal to 0. We mark this as a third equation. Now this 1 minus 1 2 that point should lies on faces. So let psi of both the lies both the surface means this point should satisfy the equation of the surface. So now we take that this point satisfies the equation of the surface psi. Satisfying the equation means psi psi values at the point should be equal to 0. So that is psi of 1 minus 1 2 equal to 0. So just equation psi, you substitute the point 1 minus 1 2. Now the value of psi is this. Okay, ax squared y plus bz squared minus 4. So here you just substitute x, y, z as 1 minus 1 2. And that value, substituted value should be equated to 0. So we get this one minus a plus 4b equal to 4, because on minus 4 is there in the equation side, that will comes to the right hand side as 4. So we mentioned this is the fourth equation. Now we are having the two equations involving two constants a and b. Okay, so you can easily solve. Okay, solving the two equation with two variables. So if you are solving, you get the value for a as 2 and b as 3 by 2. Okay, so the constants values are a equal to 2 and b equal to 3 by 2. This is the thing they asked to find out in the problem. Okay, so is it clear, girls?
Yes, ma'am.
Find the unit normal to the surface x cube minus xyz plus z cube equal to 1 at the point 1 comma 1 comma 1. Now this problem, I think this is a 7th problem in the worked out examples. Okay, I have told already when I have taught the problems. 7th problem is missed out. I will teach later. Okay, so that problem only this 7th problem, the example, worked out examples. Find the unit normal to the surface x cube minus xyz plus z cube equal to 1 at the point 1 comma 1 comma 1. So first you consider the given surface equations for surface equation as phi. So phi is equal to x cube minus xyz plus z cube minus 1. Now next one is that unit normal we need to find out. So that denote that unit normal as n vector. Now we know the formula for this one, unit normal. To find out the unit normal, this is the formula, gradient phi divided by modulus of grade phi. So just you need to find out grade phi and modulus grade phi. Here one point is given. At the point they ask to find out the unit normal. So after finding grade phi, you find the grade phi at the particular point. Then you find out the modulus value. So this is grade phi as usual. We have to find out the partial derivatives of phi with respect to x, y, z. So partial derivatives of phi with respect to x is 3x squared minus yz. That should be the coefficient of I vector. Then the coefficient of j vector is dou phi by dou y. that is minus xz. Then the coefficient of k vector is dou phi by dou z. So we are having that 3z square minus xy into k vector. So this is grade phi. Now at the point triple 111, you have to find out grade phi. So just you substitute in the grade phi xy z as 111. So you are getting this value vector 2I vector minus j vector plus k vector. Sorry, 2k vector. This is del phi, grade phi at the point 111. Now modulus of grade phi we have to find out. So modulus grade phi is root of this value is 2 square plus 1 square plus again 2 square. So we have 9, root 9. Root 9 is 3. Therefore, the unit vector is n vector is equal to 2I vector minus j vector plus 2k vector divided by this 3. This is the unit vector. So, to find the unit normal vector, this is the formula to find the unit normal vector. Del phi divided by modulus del phi.